Okay, our last set of slides hopefully will be all about normal distribution. So this was the last topic that was studied. This will be a good, decent portion of your exam. And I wanted to go through a few extra practice problems for you. I know this material was difficult for some of you, and I want to make sure that you have a good understanding of this. So remember Table B. So I'm going to just write this here. We want you to be familiar with using Table B. So I would definitely make sure that you know how to read through that table and find things that you need in the table. We will supply that table on the exam, so that's not something you have to include in your notes. So let's get started here. So let's say we tell you a little bit about a distribution. The weights of packages of fun-size M&Ms are normally distributed with a mean of 21 and a standard deviation of 1.3. So remember, it's always good to start by actually drawing the distribution. So mark where your mean is, draw it out maybe 2 or 3 standard deviations away from the mean. So find out what those values are. That would be 1, 2, and 3 standard deviations above and below the mean. Once you have this, it can hopefully be a little bit easier to visualize what the answers to problems might be. Sometimes this will help you determine if you can apply the empirical rule to answer a particular question. So we might ask you something like this. 68% of packages weigh between what 2 values? So if you remember the empirical rule, we know that if we go out 1 standard deviation away from our mean, we have 68% of our data. So the empirical rule is also sometimes called the 68, 95, 99.7% rule. That's how it's referred to in your text. The answer here would be 19.7 and 22.3. The percentage of packages that weigh less than 18.4 grams is what? So again, we can see from our graph up here that 18.4 falls 2 standard deviations below the mean. And we want to find this little percentage. So here you might remember that 95% of our data falls within 2 standard deviations of the mean. And that means we'd have 5% left over since the entire curve, the area under the entire curve is 100%. So to answer this, we would take 100% minus 95%, and that's going to give us 5%. And then we'd split that 5% into each tail. So we know half of this 5% or 2.5% would be up here. The other half is down here. So the answer here is 2.5%. So this is another way we can use the empirical rule to help us answer a question. Now, of course, we can't always apply that rule. There are times when we might ask you a question and the number that you're looking for does not fall exactly 1, 2, or 3 standard deviations away from the mean. So then you have to know how you would find a z-score, how you would standardize your value, and then how you would use Table B to find the appropriate answer. So here are a few more questions, again following with our M&M theme. So we have the same distribution, same mean, same standard deviation. You might remember I used these symbols, mu for the mean, sigma for the standard deviation. To be at the 5th percentile, a bag would need to weigh approximately how many grams? So what does it mean to be at a particular percentile? That's important to know. So remember, if you're at the 5th percentile, that means 5% of the distribution would be below you. So you're in the bottom 5% if you're at the 5th percentile. So to answer this question, you might remember there was a formula I showed you. We're trying to find a value of x, and to find that we need to know mu, and then we add that to z times sigma. So we know mu and we know sigma, but we don't know z. So we have to go into Table B and find the value of z that cuts off that lower 5% of the distribution. So quickly, here's Table B. So what I'm doing is I want to go in here and I want to look for the percentile that's as close as possible to 5. And I'm not going to see 5 exactly. I see 4.46, I see 5.48. I usually take what's closest, and 5.48 is a little bit closer to 5% than 4.46. So I'm going to go with that. And I see that the z-score corresponding to that is negative 1.6. So we're going to go back here and we're just going to plug those numbers in. X equals 21 plus negative 1.6 times 1.3. And if you figure that out, which I see that I forgot to do that before I put my slides together, so let me just pause quickly while I do my calculation. Okay, so I quickly did the calculations. That ends up being approximately 18.9. So I'm going to round a little bit, 18.9. That makes sense. So 18.9 would be here. It makes sense that we'd have about 5% less than that. What percentage of bags weigh more than 21.9 grams? So 21.9 is somewhere up here, and I want to know, what is this percentage? So 21.9, I can't apply the empirical rule because that's not exactly 1, 2, or 3 standard deviations away from the mean. Here's a case where I'd have to find a z-score. So z, 21.9 minus 21 all over 1.3. That's going to give me about 0.7. And then again, if we go to table B and look up 0.7, you will see that the percentile is 78.80%, or 75.80%. So let's just kind of quickly make sure I got the right number. So, yep, so here's my z of 0.7, 75.8. A bag that weighs 20 grams has a standard score equal to what? What does that mean? So the standard score would be z equals 20 minus 21 all over 1.3. Our standard score is approximately negative 0.8. So remember, to interpret that, we would say that this bag is about 0.8 standard deviations below the mean. So because that's negative, we know it's a certain number of standard deviations below the mean. And another name for a standard score is a z-score. So we just want you to know that. So if we ever say standard score, or we want you to standardize something, we want you to use the z formula. Okay. So a few more types of questions we could ask you. Again, we have our same distribution of M&Ms here. Mu is 21, sigma is 1.3. What percentage of bags weigh less than 18 grams? So 18 is over here somewhere. I want to know what this little area is. So to figure that out, I would take 18 minus 21 divided by 1.3, and then that ends up giving me about negative 2.3. And again, if I go to table B and look that up, negative 2.3, I see 1.07. That's my final answer. Let me go back. I just realized I made an error. So I actually did that on purpose to see if you were paying attention. So I was just thinking about this. Here I asked you what percentage of bags weigh more than 21.9 grams. And so the 75.80%, that would be what weighs less than 21.9 grams. Because again, remember that number is, or the table always gives us what's below a certain value. So I want to know what percentage weigh more than 21.9. So remember, if our question is about something that's more than, greater than, we want to take what we get in the table, take the percentage we get in the table and subtract that from 100%. So the answer here is actually 100% minus 75.80%. So it's about 24.2%. Okay, so hopefully that makes sense. So the table always gives us what's less than a particular z. If we want to know what's greater than something or more than something, then we would go to the table, find our value, find our percentile, and then subtract it from 100%. So please remember that rule. That's very important. So quickly here, this would be our final answer because we want to know what's less than or what's below a certain value. What about a percentage between two values? So I'm going to actually pause things really quickly and just write out some stuff, and then I'll come back just so I can try to wrap this up quickly. Okay, so just quickly, when we want to find a percentage between two values, remember what you have to do. You first convert each value to a z-score. So I did that over here. 19 and 22.8 as z-scores, I would get negative 1.5 and then 1.4. Then what I want to do is I go to table B and I look up the percentages that correspond to each of those numbers, each of those z-values. So for 1.4, the percentage is 91.92. For negative 1.5, it's 6.68. I would subtract the smaller percentage from the larger one, and then I get my final answer. So the process is always the same whenever you have a question that asks you about the percentage between two values, especially if you cannot use the empirical rule. You'd have to convert both to z and then find the percentages and subtract the smaller one from the larger one. Okay, finally, I have a few true-false questions related to normal distributions. So I want to know what you think about these things. 100% of the data in a normal distribution falls within 3 standard deviations of the mean. Okay, hopefully you're saying false. It's almost 100%. It's 99.7%. That would be a true statement. The normal distribution is bell-shaped. Yes, that's a true statement. So when we look at it, it has that little shape like a bell. The normal distribution is centered at the 50th percentile. That's true. So when we cut off the middle of that distribution, we have 50% on each side. The median of a normal distribution is, if the median of a normal distribution is converted to a z-score, that z-score would be 1. Hopefully you're thinking false. Hopefully you're thinking that in a normal distribution, the mean is equal to the median. They're both right in the center. And if either of those is converted to a z-score, it would be 0. So if that had said 0, that would be a true statement. One last thing I wanted to leave you with. Here's a slide that might be helpful for you. Especially if you're kind of having some difficulties understanding the empirical rule, I would definitely encourage you to look at this. It might help you answer certain questions. It can help you kind of quickly figure out percentages if you're not quite sure. So for example, if I said there's a value that's 2 standard deviations below the mean, what percentage of values are less than that? Well, if you had this in your mind, or if you were looking at this, you would know, oh, that's 2.35 plus 0.15%. That would be 2.5%. So something like this might be able to help you visualize certain kinds of problems and hopefully answer certain kinds of problems. So that's where we're going to end here. I hope these review problems were helpful in addition to the other ones that you'll find on our course site. Again, please ask a lot of questions going into the exam because we want to do whatever we can to help you feel more confident. So good luck, everyone.